Hey everyone, and welcome back. All right, so get this. Have you ever thought about the fact that like the light you see, from the sun or a lamp, it's actually like a wave? It's not just any wave, it's part of something huge. It's called the electromagnetic spectrum.
It's got all these different types of light, even the ones that we can't see.
Whoa, a hidden world of light. So how does that all work?
Well, think about like sound waves for a second. They travel, right? Light travels too, but way faster, like 1,000,000 times faster.
Wow.
And get this, light doesn't need air to move.
Oh, okay.
That's how sunlight can travel through the vacuum of space all the way to Earth.
Space is already mind-blowing, and now light is doing super speed space travel without even needing air. Okay, what else?
Well, here's where it gets really weird.
Okay.
And this is something that still makes scientists scratch their heads. Light acts like both a wave and a tiny packet of energy called a photon.
A wave and a particle. That's insane.
It is, and that's why light can do all these incredible things. Like it can travel super fast, pass through some things, but not others, and even carry energy.
Whoa.
It's the foundation for so much in our world.
All right, so we've got this spectrum full of different types of light waves. Some we can see and some we can't. So where do we even begin to explore this massive keyboard of light?
Let's start with something that you use every day, radio waves.
Okay.
These are the marathon runners of the electromagnetic spectrum. They have the longest wavelengths, and they can travel super long distances. You're using them right now to listen to this.
Hold on, radio waves, like the ones that play my favorite music.
Exactly, but it's more than music. Radio waves are also behind TV signals, Wi-Fi, and even signals from space. They can travel across the globe and even through walls. Think about that the next time you're listening to your favorite radio station.
I will never look at my radio the same way again.
Oh,
okay,
perfect.
what about microwaves? Those have got to be more than just heating up popcorn, right?
You're right. Microwaves are all about making molecules dance.
Uh-huh.
They use a very specific frequency that causes water molecules to vibrate, which creates heat.
Okay.
It's like a microscopic dance party in your food.
So my popcorn is actually doing the jitterbug in the microwave. That's wild.
And yet this, microwaves are also used in GPS technology, those signals bouncing between satellites in space. Yep, those are microwaves, guiding you on road trips and helping you find the nearest pizza place.
Microwaves are like the ultimate multitasker. What else is hiding in this invisible world of light?
Well, let's get a little stealthy and talk about infrared. Think night vision goggles and heat-seeking cameras. It's like stepping into a spy movie.
Infrared, that sounds intense.
Infrared waves are all about heat. They let us see things in the dark based on their temperature, which is why, firefighters and search and rescue teams use infrared cameras to find people in smoky or like dark environments. And you know what else?
Right.
Your TV remote uses infrared light to communicate with your TV. Every time you press a button, it's sending a coded signal using those waves.
Whoa. My TV remote is secretly a high-tech infrared messenger.
It is. We are surrounded by this technology, even if we can't see it. Now, are you ready for the part of the spectrum we know best?
Let me guess. Visible light. The rainbow of colors we see every day.
You got it. But here's the mind-blowing part. Each color in the rainbow represents a different wavelength of light.
Okay.
Red has the longest wavelength, and violet has the shortest. And this tiny sliver of the spectrum is responsible for everything we see. Flowers, sunsets, even your best friend's face.
Oh, that is so cool. All the beauty we see around us is thanks to this tiny section of the electromagnetic spectrum. Okay, what comes after visible light? Is it time for more invisible light?
It is. And it's time to talk about something that you might know from summer. Ultraviolet light, or UV rays. They have shorter wavelengths than visible light and can give you a sunburn if you're not careful.
Uh-oh. But they can't be all bad, right?
Oh, not at all. While too much UV radiation can be harmful, it's also essential for life.
Okay.
UV light from the sun helps our bodies produce vitamin D, which keeps our bones strong and our immune system healthy.
So UV light is like a powerful friend. We just have to be careful with it.
Exactly. And you know what else is cool about UV light? It can kill germs and bacteria.
What's next?
Get ready, because now we're talking X-rays. They have even shorter wavelengths than UV rays, which allows them to pass through things that other light can't, like skin and muscle. You probably know them from the doctor's office.
Yeah, X-rays are how doctors can see inside our bodies, right? That's always seemed like magic to me.
It's not magic, but it's definitely amazing. X-rays are a key tool in medicine. They allow doctors to see bones, spot fractures, and even detect some diseases. But X-rays are also used in other cool ways, too. Like airport security uses X-rays to scan luggage, and engineers use them to find tiny cracks in airplanes or bridges.
It's incredible how something that can see through us can also help keep us safe.
Okay, what is at the very end of this electromagnetic spectrum adventure?
We've reached the most powerful part of the electromagnetic spectrum, gamma rays. They have the shortest wavelengths and pack the most energy. These rays come from some pretty intense events like exploding stars and even radioactive materials.
Gamma rays. That sounds a bit like something out of a superhero movie.
They are pretty powerful. While gamma rays can be dangerous, they are also used for good. One of the most important uses is in cancer treatment, something called radiotherapy. Doctors use carefully targeted beams of gamma rays to destroy cancer cells.
Wow, so the most intense light can actually save lives. That's mind-blowing.
It is, and it shows how diverse and important the electromagnetic spectrum is.
This is amazing. From radio waves that bring us music to gamma rays that fight diseases, the electromagnetic spectrum affects everything. It really does. And we're still learning new things about this incredible spectrum all the time. There's so much more to explore and discover.
Okay, my brain is buzzing a little bit. We've covered like a lot of ground from radio waves to gamma rays. How do these waves actually, how do they work? What makes them so different from each other?
You know, it all comes down to frequency and wavelength. The electromagnetic spectrum is like a giant keyboard.
Yeah.
Well, just like each key on a piano produces a different sound wave with a different frequency and wavelength, each type of light on the electromagnetic spectrum also has its own unique frequency and wavelength.
Okay, that makes sense. But can you remind me again how frequency and wavelength actually work?
Sure. Imagine you're at the beach, watching the waves roll in.
Yeah.
Frequency is how many waves crash on the shore in a certain amount of time. If a lot of waves hit the shore in a minute, that's a high frequency.
Yeah.
Wavelength, on the other hand, is the distance between the crest of one wave and the crest of the next wave.
Gotcha. Okay, so if the waves are crashing close together, that means they have a shorter wavelength and a higher frequency, right?
Exactly. And here's where it gets really interesting. The higher the frequency, the shorter the wavelength and the more energy the wave carries. Think of it like this. A wave with a short wavelength is like a sprinter, packed with energy and moving fast.
So gamma rays, which have the shortest wavelength, are like the superpowered sprinters of the electromagnetic spectrum.
That's a great way to put it. They're like the high notes on a piano, high frequency, high energy. And radio waves, with their longer wavelengths, they're like the low notes on the piano, low frequency, low energy.
So the different properties of these waves are all because of their frequency and wavelengths, like a secret code that determines what they can do.
Exactly. And that's why different parts of the spectrum are used for different things. Radio waves, with their long wavelengths and low energy, they're perfect for communication because they can travel super long distances without losing much energy. Plus, they can pass through walls and other obstacles, which is why you can listen to your favorite radio station inside your house.
That makes sense. And microwaves, with their shorter wavelengths and higher energy, they're better at making molecules move.
Microwaves have just the right frequency to interact with water molecules, causing them to rotate and bump into each other, generating heat. It's like giving those water molecules a little energy boost to get them moving.
So it's all about finding the right frequency for the job, kind of like tuning into the right radio station. But what about visible light? Why can we see those wavelengths and not others?
That's a question that has fascinated scientists for centuries. It all comes down to how our eyes work. Our eyes have special cells called rods and cones that are sensitive to light, but they can only detect a very narrow range of wavelengths. And that range just happens to be what we call visible light.
So it's not that those other wavelengths aren't there, we just don't have the right equipment to see them.
You got it. It's like having a radio that can only pick up one station. There are all these other stations out there, but we can't hear them without the right receiver. And that's why scientists have invented all sorts of incredible tools like night vision goggles and X-ray machines to help us see these invisible wavelengths.
It's like giving ourselves superhuman vision. We're expanding our senses with technology.
Exactly. We're not limited by what our eyes can see anymore. We're using technology to explore the electromagnetic spectrum in ways that would have been unimaginable just a few decades ago.
I never realized how much we rely on the electromagnetic spectrum for so many things. It's like the invisible force that powers our modern world.
It's the foundation of communication, medicine, entertainment, transportation. It's everywhere.
But I'm curious, what are some of the more cutting-edge or unexpected ways we're using these waves today? What's happening on, the frontiers of science?
That's a great question. One area where the electromagnetic spectrum is playing a huge role is in space exploration.
Okay.
Scientists use radio telescopes to study distant galaxies and black holes.
Wow.
And they use infrared cameras to peer through clouds of dust and gas, revealing hidden stars and planets.
Space is already mind-blowing, and now we're using invisible light to see even further into the cosmos. That's incredible.
It is, and it's not just about seeing. We're also using electromagnetic waves to communicate with spacecraft. Remember those rovers exploring Mars?
Yeah.
They're sending back incredible images and data using radio waves.
Wow. It's like having our own eyes and ears on another planet. Are there any other cool applications you could tell us about?
Absolutely. Another exciting area is in medicine. Scientists are developing new imaging techniques that use different parts of the spectrum to diagnose and treat diseases earlier and more effectively. For example, there's something called optical coherence tomography, which uses infrared light to create 3D images of the eye, helping detect conditions like glaucoma and macular degeneration.
So we're using invisible light to see inside our bodies in even more detail. It seems like the possibilities are endless.
They really are. And here's another one for you. Did you know that scientists are using terahertz waves, which fall between microwaves and infrared light, to develop new security screening technologies that can detect hidden objects without using harmful radiation?
Wait, so we could have airport security scanners that can see through clothes but don't use X-rays? That's incredible. What's the catch?
Well, the technology is still in its early stages.
Okay.
But it has huge potential. Terahertz waves can penetrate materials like clothing, paper, and plastic, but they're absorbed by water and metals, which allows them to differentiate between harmless items and potential threats.
That's fascinating. It's like science fiction becoming reality.
It is, and it's a reminder that we're only scratching the surface of what's possible with the electromagnetic spectrum. Who knows what incredible discoveries and applications await us in the future?
This has been an amazing journey through the world of invisible light. I feel like I've learned so much about the science that surrounds us every day.
I'm glad to hear it. It's a reminder that the world is full of wonders, even in the things we can't see.
Okay, we've gone from radio waves that can connect us across continents to gamma rays that come from exploding stars. It's incredible to think about this whole invisible world of energy that surrounds us. But I'm curious, is there anything beyond gamma rays? Like what's next on the electromagnetic spectrum?
That's a great question. It's kind of like asking what's north of the North Pole.
Mm-hmm.
Gamma rays have the shortest wavelengths and the highest energy that we know of.
Okay.
It's possible that there are other forms of electromagnetic radiation out there that, we haven't discovered yet. But for now, gamma rays, those are the end of the line.
So gamma rays are like the ultimate boundary of the electromagnetic spectrum. It's pretty mind-blowing. But I have another question. We've talked about how scientists use different parts of the spectrum to study space. But how does that actually work? I mean, how can we use something like radio waves to learn about things that are billions of light years away?
Well, imagine you're listening to a radio station.
Yeah.
The radio waves carrying the music, those are traveling through the air to reach your antenna.
Right.
In a similar way, objects in space, like stars and galaxies, they emit radio waves too.
Oh.
And these waves travel through space and can be detected by giant antennas called radio telescopes here on Earth.
So it's like we're eavesdropping on the universe's radio show. That's so cool. But how can radio waves tell us what these objects are made of or how they formed?
Well, each element in the universe, it emits radio waves at specific frequencies. Kind of like a fingerprint. By analyzing the radio waves coming from a distant galaxy, scientists can determine which elements are present and even how much of each element there is.
It's like cosmic detective work, using radio waves to uncover the secrets of the universe. What about infrared? How do scientists use that to explore space?
Infrared is great for seeing things that are hidden from view by clouds of gas and dust. You see, visible light gets blocked by dust, but infrared waves can pass right through it. So by using infrared telescopes, astronomers can peer into the heart of star-forming regions or study the atmospheres of distant planets.
So it's like having X-ray vision for space. We can see through the cosmic fog and uncover hidden worlds. This is truly amazing. I'm starting to understand why scientists are so excited about the electromagnetic spectrum. It's like a key that unlocks so many mysteries of the universe.
Exactly. And we're still just, scratching the surface of what we can learn with this incredible tool. Who knows what amazing discoveries await us in the future?
That's what makes science so exciting. There's always more to learn, more to explore. Well, this has been an incredible journey through the world of the electromagnetic spectrum. I feel like I've gained a whole new appreciation for the invisible forces that shape our world and the universe around us.
I'm glad to hear it. And remember, curiosity is the key to unlocking new knowledge. So Keep asking questions, keep exploring, and keep your minds open to the wonders of science.
That's great advice. Thanks for joining us on this episode, everyone. And remember, the electromagnetic spectrum is more than just a science lesson. It's a symphony of energy that connects us all. Until next time, stay curious.